Hey, imagine you inherit some code that's hard to read or just to understand. It's too clever or it's too confusing or whatever. I'm going to try to change your mind about that code, whether it's good or whether it's bad. But first, a little story. This code here, right? This hello world code. This is Java. This has an anonymous inner class or just an inner class. The Java I learned in university looked a lot like this. It was Java 1.x, and they taught it to us a very simple way. They said, like, in Java, everything is an object. It's easy to remember. It's one concept, right? And so we would write a lot of swing code. This isn't a talk about Java, by the way, just an example. But we would write this swing code, and it was always full of these anonymous inner classes. Like here, new action listener. Like you were writing that over and over again. It was like so much boilerplate. But then Java got lambdas. All of a sudden, the code got a lot nicer. Look at this. You just do E arrow, right? So much simpler. And my greeter code from before, like even easier, right? All you got to do is system.out.println inside my greeter. That's my implementation with the lambda. This is so much nicer, right? When you have less boilerplate, not only is it less to type, but it can often be easier to read, and there's just fewer places for bugs to hide. If you look at an old-fashioned if assignment that we all know and love, right? There's a number of ways that this can go wrong. We have, setting y to various values, but we could simplify that, right? If our language supports if expressions, we can assign the y, to the if expression. And there's just less code there. It's just not like y equals y equals y equals. It's simpler, right? It's shorter, it's expression-based, there's less room for error. It's an improvement in code, but it's gonna lead to our readability problem. Here's another example, const expressions in C++. Here, I am calculating the area of a circle of radius 5, and I could do that at compile time, right? This value is going to be calculated at compile time, even though it just looks like normal C++ code. You just have to add this keyword. Super cool, right? Before const expression existed, you'd have to do macros maybe, and it would be complicated and a mess. I'm not a C++ programmer, but this is pretty neat, right? And syntactic sugar and more language features are a net win for experienced users. They just make code easier to read in a lot of cases. But there's some downsides. Why did Java succeed so much when it was so simple in those earlier versions? And now it's getting more complex, right? Why is Go succeeding so much now? Why are so many people using it when it's a very simple language? Why do people have so much aversion to C++? Because it has a lot of features, right? And that can be hard to learn, right? It's all about the learning curve. There are lots of factors besides expressiveness, besides what I've just shown, removing boilerplate, right? The learning curve matters. And also, if your language is very complex, it can lead to what I call the showboating problem, to showboaters, which we'll get to and ties into this readability thing. But basically, expressivity has a cost. Is expressivity a word? I don't know. But expressivity does have a cost because these concepts, they add complexity to the language and then they just make learning harder, right? You get something like this, right? Where when I first was taught Java, it was like everything is an object, right? And then it was like everything's an object except for primitive types. And then, okay, we had to have a footnote about lambdas, which is just a syntax for doing this anonymous inner class. And so everything's still an object if you squint, but not really. Even when these concepts fit all together nicely, which I don't think the Lambda one does, it's just more to learn, right? If you want to learn modern Java, you need to know the streams API. It's just important. And it's worth learning, right? The complexity of the language has a benefit because you can write things more concisely, but it hurts beginners, right? It hurts beginners learning from simple examples like that, but it's not just that, it's that these things compound. I can show you a feature of a language in isolation and how it makes things better, but real world code is going to use all of these concepts together, right? And practice experts will use all the language features that help in a certain area, and putting them all together can just be a lot. In an expressive enough language with developers really pushing what they can do, you can end up with something like The Focused in A Deepness in the Sky, which is like, it's like a fantastic book. I really recommend it, but I don't want to spoil anything. But in it, there's these groups called The Focus, and they work together. They're like geniuses trying to solve problems. But if you leave them at it too long, they develop all this internal jargon. Nobody can understand what they're saying. They might solve an important problem, but they can't communicate it to the outside world because their internal idioms are so rich and complex that it's impossible to unpack, right? Which leads me to code like this, right? This is a service call using, like typed effects in Scala. I mean, you might not even want to try to read it. But imagine you're a developer, who's familiar with Java 8, and you inherit a Scala program. It's on the JVM. This should be easy. and you open it up and it looks like this. It's written in this functional effect style. This is a bit over the top, but I think your reaction to this is a real thing. We've all been there, right? Where we expect one thing and we look and we're like, oh my God, what's going on here? Let's look at some more examples. I want to kind of pull this apart. So Code Report has this awesome YouTube channel, and he does LeetCode code problems in various languages. So this is a simple problem, maximum count of positive integers. This was LeetCode code 2529. Check out his video. But here is a Go solution. This is really simple, right? We have a for loop. We're just counting up positive and negatives. And then if positive is greater than negative, we return positive else negative, right? It's pretty simple. I think that this code is even easier to understand probably than the description. But we go to different languages, right? I don't know C++. His C++ solution looks like this. It's a lot less code, but it uses concepts that I'm not familiar with, right? It has lambdas, which I don't totally understand the syntax in C++. It has count ifs. It has ranges. You need to understand, what is the type of a range? Is it an iterator? I don't know. The solution is a great solution if you know C++, but if you don't, you might not understand it, right? Same with this Rust solution that he develops. A little bit different approach. He's going to take the nums, make them into iterators, and then filter them and count them, and then return the max. So here there's a couple more concepts to learn, right? You need to understand filter and how max works and how iterators work, and I guess he's using clone here. So how cloning works. I'm not saying the solution is bad. The solution is small. It's concise. There's less for things to go wrong than in the Go solution. But a Go programmer might look at this and say, why do I have to learn all these concepts? Like, why do I need iterators for this solution when the Go solution is so simple, right? It's a legit question. And if we push this all the way, which Code Report always does, right? Here is a J solution. I guess it uses DIDAC operators, but makes sense to somebody who understands array languages and J, but like I don't understand what this is doing at all. But I think it's important to contrast this or our previous two solutions with this that we looked at earlier, right? The effect code, because they're very different, right? The J solution is using the concepts of an array language appropriately, and this Scala effect solution is not, right? It's showboating. It's showing off how you could possibly solve a problem using a certain way to track effects. Maybe they're kind of showing off what could be done. Maybe they're just trying to entertain themselves or entertain other people who have pushed the limits of the type system, right? And there's value in that, but not in code you want to inherit, right? Maybe in a side project, maybe in a presentation, but don't commit this to your code base, right? Because this is showboating. This is not being done for the appropriate reasons in a practical work context. That's how I would describe it. But I think pure showboating is pretty rare. What often happens is something a little bit different. Like if you know all the intricate features of a language, then you might reach for those solutions when you're creating something. And it might not be apparent to you that this will make newcomers struggle. It's just the obvious way to structure the solution. It's often called the curse of knowledge, right? You don't know what they don't know. And so you make something that may be hard for new people to understand. And that's fine, right? And not everything's written for beginners. Also, if you learn about a new technique, you might just want to use it even when it doesn't make sense, right? Like this Go code here doesn't make any sense that they're using channels here. Yeah, if you learn a new technique, you might want to use it even when it doesn't make sense. You might, to develop your understanding, push it into places that it doesn't make sense, like this Go code that's just adding up numbers, but in a very unique way. That's another reason that this happens, right? It's not out of aggression. It's somebody pushing things too far. For learning purposes, maybe, right? So you use some constraint, right? Everybody goes through this maximalist phase where they learn some new feature and they want to use it more than it should. They want to push this concept to its limits, and maybe that's how they understand it. But do that in a side project, right? That's maybe don't do it in something that somebody else is going to inherit after you leave this team or whatever, and they're going to need to figure it out. This is a ray tracer in length, or like a very small portion of it. And this whole ray tracer is written as one giant link expression that's like, 100 lines long. It's neat, right? It is showboating, showing what can be done with link expressions and how to combine them and stuff. But if you're working on a team, man, don't commit this code. Nobody wants to have to deal with this when you have to make a change to it. That's too much, right? Showboating is for side projects and for playing around. I don't know. Don't commit it, right? But also, right, going back to the original question, you encounter some code, you don't understand it, you might have to hold your opinion, right? It's hard to judge that J solution if you don't know J. This could just be a familiarity issue, right? The foreign looking code may very well encapsulate the problem in a way that you're just not familiar with yet, that you don't yet understand. Maybe not, right? Some people are bored and they come up with complex solutions. They make things harder than themselves or invent new idioms or use the wrong tool for the wrong job. That is a thing that happens, right? Programming language features make code clearer often, but each new feature is also something that can be abused to write horrible code. That's just the reality. So if you inherit some bad code, that might be what it is, but withhold your judgment, right? Until you know the idioms that are in use in that area, in that library, in that language. Just wait. You won't be able to tell which is which until you understand what's being done and why. Yeah, and if you're looking to learn more about building software, yeah, subscribe to the channel, but also check out Earthly, right? I work for Earthly. This is the Earthly channel. Earthly is like a makefile brought into the future where you can get builds faster, you can get builds in parallel. It works with your existing CI. It's just better. Earthly's easy to learn, and it will make your CI process a lot better if you have a build script that looks like that Scala effect system, which many people do have some ugly, scary piece of a build. Earthly can help solve that, but also just make things faster with caching. And it works locally, so you don't have to do that commit, push, wait type of deal over and over and over again. Yeah, also just let me know what you thought of this video. My favorite part of making these is just hearing what other people think, and then often like your comments will lead to my next video about some other topic. So disagree, agree, let me know. And until next time, thank you for watching.